My name is Lucas, and this is the first iteration of my second long-term project this year, the SAR ADC. In this project, I'll explain its clock circuit. So, first of all, this is a ring oscillator. It's built using two inverters, two resistors, and two capacitors. So continually switches between high and low states, creating oscillating output. It's kind of interesting because it has no input. First of all, this chip, we use two NOT gates of the 6. There's two 510 ohm resistors and two 0.1 UF capacitors. So how this circuit works, when power is applied, the circuit starts at a random state. So when the capacitor charges through the resistors, you can see it on the Fallstadt diagram. When the capacitor is charged through these resistors, it causes a delayed voltage change at the inverter output. Once the voltage crosses over the switching threshold, the inverters flip their output, and this kind of repeats forever. This creates the continuous oscillation. The oscillation frequency depends on the resistors and capacitor values, making this perfect for clock generation, as you can change the frequency to be whatever you want. And actually, first you can measure this frequency using a DMM. You can see here it's about 10 kilohertz. This can also be calculated using the equation frequency equals 1 over 2 times the value of the resistor times the value of the capacitor. This also gives you the frequency value. So basically the resistor and capacitor values, the larger values equals slower blinking. Even if we plug an LED into the output of this circuit, it's flashing so quickly at about 10 kilohertz that even if we plug into an LED, it just looks like a solid light. You can't even see it blinking. Anyway, this was my project, 3.4.1, the SAR ADC. This is the clock. Thanks for watching.